Hopefully you're able to fly through this next page here. We're just doing some foiling here. It says perform the operations as indicated and simplify your answer. Again, the issues in calculus are not calculus. The issues in calculus are algebra. You've got to remember how to do these steps, and you cannot make any errors in these steps or you will get these problems wrong. So if you remember, you have to remember the term was FOIL, F-O-I-L, and the idea was you did the first, the outer, the inner, the last. So when you distribute this, you're going to do the first two terms together. First terms being a 2x times an x. So let's go ahead and write that out. You do not need to write this every single time. I'm just doing this for your benefit this time. So the first would be 2x times x plus the outers. The outer would be a 2x times a negative 4. So I'm going to go ahead and write that plus 2x times a negative 4. Now I need to do the inners. The inners would be the 3 times the x, so that's plus 3 times x. And then the last would be the 3 times the negative 4, so plus 3 times negative 4. So that's what FOIL is, first, outer, inner, last. Hopefully this is super, super easy for you. You absolutely remember how to do this. Let's just simplify from here. 2x times x is 2x squared. 2x times negative 4 is a minus 8x. Plus we have our 3x, which we're going to combine those like terms, and then we have a minus 12. So again, we need to combine those like terms to finish off this problem. We would have a 2x squared minus 5x minus 12 is our final answer on this problem. Okay, so that's what foiling is. Remember, if you're going to distribute on example B, we have x minus 3 times x squared minus 2x plus 5. If we have to distribute more than two terms, we can't call it FOIL, but that's essentially what we're doing. We're just going to take this x and multiply it times every term. Then we're going to take the negative 3 and multiply it times every term. So let's think about this as the first one. If I did x times x squared, I'd have x cubed. Now I need to do the x times the minus 2x, so that would be minus 2x squared. We do the x times the 5, which would be the plus 5x. Now I'm going to distribute the negative 3 through. So I'd have a negative 3 times x squared, which is negative 3x squared. I'd have a negative 3 times a negative 2x, be careful with your sign, would be a plus 6x. And I'd have a negative 3 times a negative 5, which would be our minus 15. So all I did for that was I distributed the x to each one of the terms, and then I distributed the negative 3 to each one of those terms. Now what do? Combine like terms and simplify. We have our x cubed, that one's gone. Okay, I'm going to combine my x squared terms. I have a minus 2x squared and a minus 3x squared would give me a minus 5x squared. I have a 5x and a 6x, which would be my plus 11x. And then I have my minus 15. Again, no further simplification needed. We've combined all like terms. We've written it in descending order, so our final answer is x cubed minus 5x squared plus 11x minus 15. Let's keep on moving on to the next problem. Again, this is another problem that a lot of students miss. I would see a lot of students on the test say that this is x squared minus 9 or x squared plus 9, and that's absolutely wrong. When you have subtraction, you cannot just distribute the square. Remember, you can only distribute the power if and only if it is multiplication or division. Never, ever, ever distribute the power if there's addition or subtraction in the problem. So what would you do here? Well, go back to the fundamentals of remembering what it is to square something. All it is to square something is multiply it times itself. So if you want to simplify x minus 3 quantity squared, or FOIL it out, you actually need to FOIL. You can't just square each term. So the first would be x times x, which is x squared. Outers would be x times negative 3, which is negative 3x. Inners would be negative 3 times x, which is negative 3x. And the last, negative 3 times negative 3, which is a positive 9. Combining like terms, we'd have x squared minus 6x plus 9. Way different than what we would have had if we just squared each term. So always remember, when you have a power of squared, something raised to a squared with addition or subtraction, you must, absolutely must separate and FOIL. Absolutely FOIL those problems, a simple algebra error to make on the test. Same thing over here with d. It's the quantity 2x plus 3 squared. Again, we cannot distribute the power because it is addition or subtraction. You can only distribute the power with multiplication or division. So let's look. We'd have 2x plus 3 times 2x plus 3. If we did our first, that's 2x times 2x, which would be 4x squared. Outers, 2x times 3, which is 6x. Inners, 3 times 2x, which is 6x. Last, 3 times 3, which is 9. Combine those like terms, the 6x with the 6x, we end up with 4x squared plus 12x plus 9. No other simplifying needed to do. That's it. So many times we are going to need to expand or multiply out different factors. Be comfortable with doing that. Factoring polynomials, you absolutely need to know how to factor polynomials. One of the things, if you get stuck factoring, is you can always use that quadratic formula. So make sure you have that quadratic formula memorized. Again, the quadratic formula being negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient on x squared, b is the coefficient on x, and c is the constant, the number by itself. So that's the quadratic formula. To give you a nice little example there, it tells you what the quadratic formula is. So when do I use the quadratic formula? Only if it's not easy to factor. If it's easy to factor, I factor it. If it's not easy to factor, I don't factor it. Okay. What are some of the things that you should remember how to factor? Certainly you should know difference of squares. So for instance, x squared minus 9 factors into x plus 3 and x minus 3. Notice that x is a square and 9 is also a square. So that's difference of squares. You're going to factor those numerous times this semester. Sums and difference of cubes. You need to remember the formula for sums and difference of cubes. That's what the next two are right there. If you don't know these formulas right now, I highly recommend that you write them down. There's some sayings to help you out with memorizing them. It's SOAP is the saying. SOAP stands for same, opposite, always positive. So what am I talking about? If it's x cubed minus a cubed, so this is a difference of cubes and it's subtraction, the first sign is the same, so that's subtraction. The second sign is the opposite, so because it was subtraction, that one has to be addition. And then the last one is always positive. If you notice, that works with the sum of cubes as well. Because it's positive, you're going to do same, which would be positive, opposite, which would be negative, and then that last one is always positive. So SOAP helps you remember the signs when factoring sums and difference of cubes. Okay, the next one, it says the Binomial Theorem. All that's saying is anytime you have addition or subtraction, quantity squared, you can't just square each term, you actually need to FOIL it out. So that's what it comes down to. If you notice, it's the first term squared, the last term squared, and the middle term is always twice the first times the second. Twice the first times the second. So again, if I looked at this and I have x plus 3 quantity squared, I could either FOIL it out, or I could say it's the first term squared, the last term squared, and then it's twice the first times the second. So 2 times x times 3 would be the 6x. So up to you. Quite honestly, FOILing is probably easier than trying to memorize all these formulas, but again, that's up to you. All right. So you do have to remember how to factor. We're going to be factoring numerous times this semester. So please make sure you can do that. It says find all real zeros of each polynomial. So what's a real zero? A real zero means literally just set it equal to 0. Find the values of x that you plug in and you get 0. One of the biggest techniques for doing this is factoring. So I need two numbers that multiply to be the constant. The constant here is negative 15. Those same two numbers need to add to be the middle coefficient. The middle coefficient here is the number negative 2. So they need to multiply to be negative 15 and add to be negative 2. I think those numbers would be careful with your signs. How about a negative 5 and a positive 3? Make sure that it works for both of them. Negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So those are my two numbers. Those turn into my two factors. I would have an x minus 5 from the negative 5, and I'd have an x plus 3 from the positive 3. Now I have properly factored it. Of course, I could take a quick second and FOIL that out to make sure I factored it properly. And then we use the zero product rule. Two things multiply to be 0 if and only if the first equals 0 or the second equals 0 or both. Solve those, add 5 to both sides, I'd have x equals 5. Subtract 3 from both sides, I'd have x equals negative 3. So my answers, I try to write them in order from least to greatest. That I would give you full credit if you wrote it the other direction, but I always think about a number line, left to right. I try to write my answers in proper order, so I'm putting negative 3, comma 5. If you put 5, comma negative 3, you would have gotten full credit as well. Let's look at this next one right here. I need two numbers that multiply to be the constant, which is 1. Those same two numbers need to add to be the middle coefficient, which is 2. Think about your numbers and your factors here. I'm looking at the numbers 1 and 1. So to me, this would be x plus 1 times x plus 1 equals 0. Or another way you could have seen that would have been x plus 1 quantity squared equals 0. Doesn't matter which one of those you want to solve. You're going to solve by setting x plus 1 equal to 0. You could either set each factor equal to 0 or take the square root of both sides. Subtracting 1 from both sides would give me x equals negative 1 as my final solution. How do I know these are zeros? What can I always do? What should I always do? If you have extra time during the test, plug those numbers in and make sure they work. What do I mean by plug those numbers in? Let's look at this second one, for example. Here's the number negative 1. Plug it into the original problem. We should get 0 because it's called a 0. So negative 1 squared is 1. 2 times negative 1 is negative 2. So 1 minus 2 would be negative 1. Plus 1 would be 0. So if I plug in negative 1 into that equation, I get 0. That's why it's called a 0. Same thing here. If I plug in negative 3 or 5 into that expression, I should get 0. Indeed, I do. So that's how I know I found the proper zeros for the problem.